You cannot measure green sand control even till today. If you increase active clay, you impact 8 properties of the sand simultaneously. And now you can't see the sand, you can't feel the sand, it is moving with tremendous velocity in highly automatic molding lines.
With the current access to technology that they have, how should they be testing today? What is, your opinion, what is the best way to test?
I think that we are on the forefront of technology transformation in the industry. How do you handle a 20-year experienced guy leaving your foundry tomorrow, even with a 60-day notice?
Please summarize Sandman in one line for me, or maybe a couple of lines. Like at its core, what does it do for a foundry?
Are you ready to understand and embrace technology? Is the question that every foundryman should ask. The most dangerous type of waste is that which we do not recognize.
A lot of foundries are tracking their capital investments, their labor, and all the other assets that they have in their companies. But I think the main thing they are missing out, and something that they already have but they are not leveraging, is their data, which is something that Mr. Deepak Chowdhary has really pioneered and enabled foundries to take advantage of the data that they have, especially for Greensand, right? Because I think you're
right.
mainly a pioneer with Greensand technology.
That's been my passion.
Right.
Yes, that's true.
Right. So Mr. Deepak Chowdhary is, of course, very well known. He is the founder and chairman of MPM and very recently Sandman, which is mainly what we are here to talk about today. Right?
Right. Take it the way you want to.
So thank you for having us.
Yeah.
It's a real pleasure to be here. And let's just start with your background. So I recall that you told me you moved here when you were about 33 from Mumbai.
Yes.
And at that time you were doing a lot of trading, a lot of selling various
various products.
Correct.
True.
But you primarily started and you focused on the foundry industry here when you came to Nagpur.
No, not. I would just correct you there. I started in the foundry industry out of college in 1979, as I told you.
Okay.
Where I had pioneered the product hydrocarbon based additive for green sand systems as a first generation entrepreneur, by the way.
Right.
To improve the surface finish of castings and to prevent casting defects related to sand. That was the start. So 79 to date has been almost 45 years now.
Okay.
In this industry. It's been a long time.
Right.
Yeah.
And coming back to that, Greensand is also a technology as old as the sands of time.
Yes.
To especially be innovating with Greensand even till this date is already pioneering work. So I think that is mainly what drove me here and something I really wanted to talk about. So if a person today is running a foundry and they are using Greensand, right? Now Greensand can be looked at something that is very, very basic. You use this in this combination and you go ahead and you get your Greensand. But you have looked at it as a science now, right? And you have gone very deep into the subject, correct? So if someone were to ask you, what is your understanding of Greensand and what do the various additives in Greensand actually represent, what would be your answer to that?
Yeah, that's a great question, but it also begs a very complex answer.
Right.
So as you have rightly said, Greensand is supposed to be a very simple admixture of 4 main additives: water, sand, carbonaceous additive, and clay, that is bentonite.
Okay.
Now this simple mixture, when it is put into a sand loop with varying degrees of sand metal ratios, core to metal ratios, bunch weight of the castings, etc.
Correct.
It becomes very complex. Because now the sand, the moment you start operating that foundry with green sand, you are giving life to a complete, a sort of an animal that is constantly energetic, evolving, moving, dynamic, very difficult to control.
Right.
And every foundryman in the world would agree with me if I said that it is the greyest area of the casting process. Every other area in the casting process has a definitive solution, like you can test metal, you can do a spectrography on metal, you can measure the modulus of a sleeve when you are doing methoding. But you cannot measure green sand control even till today.
Okay.
So it has always remained in the realm of experiential capability. the know-how gained by years of experience in managing systems. So by the same definition, it was always also called an art. And if you notice my tagline, which I'm not wearing my t-shirt today, my tagline when I invented Sandman was from art to analytics.
Okay.
That's the tagline of Sandman.
Right.
Because this art form, while it was necessary in those days when Foundrymen did not have the benefit of the concept even of analytics as it has developed in the last 10 years, and on which I was the cusp of in 2011 when I looked at data analytics as a solution for what I was doing as an experiential foundryman, understanding the fundamental data of sand samples which I used to collect from foundries and give them predictions and even a human interface prescription of what they should do even if they were 1,000 kilometers away to help them reduce certain aspects of their defects.
Right.
And which became very successful for me and actually propelled me into the level I was and still am today as a recognized foundryman in this industry.
Right.
This was not possible because there was no data capturing, collation, authentication. So if you permit me to just give you more insight into this, that even today most foundrymen in the world, I would say,
right,
have a linear relationship with data, with the sand properties. So we have blowhole, they will normally see what is the moisture content of the sand. Or if there's scab, they will say is my active clay very high. But as I show when I demonstrate Sandman in the matrix of the interrelationship of properties, if you increase active clay, you impact 8 properties of the sand simultaneously.
Okay, because they are all correlated.
They are all correlated.
Right.
In less or more positive or negative correlation is a different aspect, but they are correlated. So if anybody thinks that he's just adding 1 kg of bentonite into the system, he's increasing, and by that he will get a higher active clay, for sure he will. But he might also get a higher GCS, he might also get a higher WTS, he might also get more dead clay. So there can be pros and cons, which is very difficult to understand on a human interface level, right? Because now you are going into multilinear relationships, multivariate relationships, and that is not possible by the human brain anymore. So to give you a concept of where I look at this industry and the sand systems, which I have evolved over these 45 years, I also had some sort of linear and multilinear relationships, but maximum 2 or 3. But what has really evolved and what has compounded this need to understand the sand system better as a science. In the earlier days, a 500-ton foundry per month was considered to be a big foundry. Okay. Today, the entry level is probably 3,000 and 5,000 is considered to be a medium-sized foundry. That is a huge gap. It's 10 times bigger than what it was 30 years ago, 40 years ago when I started my career. The systems were what jolt squeeze, that duck, 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 duck. And now you can't see the sand, you can't feel the sand. It is moving with tremendous velocity in highly automatic molding lines.
Would you say the reason for this upgrade in a medium foundry now going from 500 to 3,000, 5,000 would be conversion of an art to a science in many ways?
Yeah, I mean, I felt even in those days that we need to have a scientific approach on how to handle green sand systems because the sand still produces defects.
Correct.
And by the way, in one of my pitches, I said defects are common across foundries globally. It's not only an Indian phenomenon.
Correct.
Some suffer less and some suffer more. But it is a uniform occurrence. And the important thing is to control it, you have to understand what is creating the noise in your system. And once you have a handle on the noise, you have a handle on the defects. Defects are never controlled by design. They are controlled by process control. If the process is good, you will have less defects. If the process is unstable or what we would say imbalanced, you will have more defects, right? So the understanding of how that sand system is looping and the advent, of course, of jolt squeeze molding capabilities to high pressure molding lines. I have a clarification for all those who care to listen We use the word high pressure molding line.
Correct.
Including the manufacturers say they are high pressure molding systems. I say they are high pressure, but they are high density molding systems. Why do I say that? Because when you subject that sand into high compaction pressure, you are increasing the density of the mold.
Right.
So when you articulate the process of the molding from pressure to density, you completely change the understanding of how you have to deal with sand.
Right.
Right? High pressure by itself has no definition except that you are exerting pressure.
Correct.
But density, then you try to understand how much is the permeability, what is the received distribution of my sand in that mold,
right?
How is that mold going to behave
right.
when it is subjected to heat, to the generation of gases, etc.
Right.
This is what starts a person thinking. So what I say is that you first articulate the problem statement or you define the process clearly. Once the definition is clear, then you understand how to deal with it. Then you add all the, what I told you about the simple mixture going through various metamorphoses because of the changing system.
Correct.
Can you imagine how much you are compounding that green sand, that simple black looking sand which we call green sand,
correct,
into such a complex phenomena?
Correct.
And people might say I'm overstating it, but I'm not overstating it. Because if foundries realize that a 1% rejection in a 5,000 ton per month foundry translates to approximately 75 lakhs per percent, into 5,000 tons is 3.75 crores approximately that can be saved by 1% saving. It's a 5,000 ton per month foundry we are talking about, let's say.
Right.
But the definition is not about the loss. The loss is just to shock you into thinking, what am I losing because I am not controlling my process? But a process control manager is not going to be thinking about the loss that is going to happen at the end of the cycle.
Correct.
He wants to run that process in such a smooth way that it is humming along.
Correct.
Right? When you drive a car, a great car, if you're driving, whether it's a Mercedes or a Rolls Royce or whatever it is, or you're in a plane, what are you looking for? You're just looking for a smooth ride without any hiccups on the way.
Right.
Right. Especially when you're flying, right?
Correct. So you also said something that was very powerful. You said that you would term high pressure molding as high density molding.
Yes.
Correct?
Yes.
And the reason you would term it as that is because when you compact sand to that strength, right? Are we really testing for those properties in our labs? Because I think that is something that
you could ask me that question and I would answer very clearly that unfortunately, up to date, things are changing, but up to date, Foundrymen have never had the luxury of very precise measuring instrumentations. Point number one.
Right.
Point number two, they have never had the luxury of going from the sanitized laboratory conditions of test methodology to actual thermophysio loading of the sand.
Real world conditions.
Which happens in the real world on the foundry shop floor.
Right.
And there's a big gap between these two things. And just to illustrate, when we were talking and I mentioned to you that if you just take a small simple test like permeability, right?
Correct.
And you say I've got 130 permeability, I should be doing fine, why am I having blowholes? Right? But you're testing in a laboratory which is sanitized for testing process, so you're just pushing air through a sand sample and the velocity of the air passing is giving you 130.
Correct.
Now let's say that we put a coin on that top.
Right.
Sort of throttling that's 2-inch sample by say 1-inch coin.
Correct.
Does the permeability drop? What do you think?
This is something that you mentioned earlier and I was really zapped at the answer. So, right.
So it doesn't drop because the principle of physics is that the air will escape through the available route in a much faster and with more velocity, but it will still give you 130.
Correct.
And now let's go to real world conditions and you heat that coin to 150 degrees or 120 degrees and then place it on top of that same sample. As I told you, the permeability will drop. Why? The sand sample is the same, the circumference is the same, the air pressure is the same, the test measurement. It's because now that heat is driving the moisture down from the sample top portion to below, and therefore it is creating a more throttling effect in the sample, and you might get a permeability reading of 110.
Okay.
That's your answer.
Right.
So now what are you really looking at? How much moisture is there in that sand sample?
Correct.
It is no longer just a sand sample for testing permeability. You have given it a different dimension.
And what if people are taking actual inputs from that system that they're testing on, and they're making changes on the green sand? It's almost like, you know, you're getting a wrong reading.
Yeah.
It's like a wrong diagnosis, and you're giving someone a cure for a disease they don't have.
Yes, it is. It is actually. I would not use the word wrong diagnosis because it is not happening by design. For, as I told you, I qualified my statement by saying that Foundrymen have never had the luxury of having thermophysio capabilities to evaluate the testing. It is not the fault of the user. It's actually the lack of the technology maturing to that level where you can actually load the test sample of the lab under actual thermophysio conditions.
Correct.
And then get your answers, right? So for example, these things are happening in the foundry world. For example, there are developments taking place where you can test a cookie of sand is being pioneered by gentlemen by foundry technologist by the name of Dr. Ramratan in Western Michigan in US, where he loads the sample at almost 1400 degrees C. You can exactly know at what level the resin is breaking.
Okay.
So you can actually qualify that sample and the resin precisely before you make more defects.
Correct.
So a lot of things are changing in the foundry world, but they will take time for it to filter down to foundrymen.
To become mainstream.
Yeah, so ideas can be only translated when somebody takes it and brings it into instrumentation.
Correct.
Right. That sometimes takes a lot of time, but many changes will happen, and there are many machine manufacturers who are also looking at it very progressively and trying to do many tests so that there's a saving in time plus actual working conditions are mimicked.
Right.
All these machines are designed to compact a volume of sand into a mold.
Correct.
So they are molding machines, and I say they are compaction machines.
Correct.
You can term it in whatever term.
To make it
highly sophisticated,
right,
highly automated, very precise. Those are the qualifications of that engineering that goes behind it. But ultimately, they are designed to deliver a compacted mold to the line in which you will pour metal and produce a casting.
Correct.
But the mold is going to decide the fate of the castings, not the machine.
Right.
The machine is only handling the available quality of sand. If the quality of sand is not mulled properly, is not prepared properly,
right,
and the proper analysis, design and technology of that sand control is not applied, the machine is only going to spit out what you have put in.
Right. True.
So you put in a crappy mold, you are going to get a crappy casting.
Correct.
Right? So these are the things that we need to understand, define. What exactly are we looking for an output from that machine? Many people think the machine is the solution for the mold. It's wrong. It is still the sand which is the solution that the machine is delivering to you with value.
Correct.
Proper pressures, proper shape, integrity of shape, and everything goes into it and gives you a proper mold. So when the whole system works in unison or in synchronization and in harmony, then you get a great casting. But if there's imbalance in any of these processes, you are not going to get a great casting. Right? And it takes the foundry or the line manager or the foundry manager to apply his mind to the design of the system's operation rather than doing the micromanaging of the sand.
Correct.
Is what I always say. Because the heavy lifting doesn't have to be done by you with modern technologies like Sandman. We take care of all that.
Correct.
We give the prescription of what the next mix should be with a 0.7 RMSE. With that kind of accuracy, right?
Correct.
So why do you need to do this micromanagement and heavy lifting, right? When you drive a Mercedes or you drive any good car on the road nowadays, almost all the cars are reaching certain levels of performance.
Right.
right? You're not looking at what is the compression ratio of the carburetor and all that kind of stuff, or
Correct.
the piston.
You don't even have to get into it.
You don't even have to get into it. You need to drive carefully.
Right.
You need to plan your route, right? And make sure that you stay in your lane.
Right.
And don't jump signals.
Correct.
Right? Don't create a noise while you're driving. Similarly, when you're doing sand preparation, don't create a noise. Is all I'm saying.
Correct.
Once that is understood, when the problem definition is clear, and let me tell you that I completely disagree with any person who says I don't have the ability to understand what the system is. Everybody in their heart knows, every foundry manager in his heart knows what is going wrong with the system. Important thing is, does he give himself the time to understand the system rather than get lost in the micromanaging of the system?
Correct. So you mean what is lacking is a foundry manager going above like an eagle and looking at all the processes and then deciding what they should actually do?
Yeah.
Okay.
Yeah.
Right.
Now, if I am chairman of my company,
correct,
and I go to my purchase manager and say, what was the price of coal today?
Correct.
And what is the index of coal? I mean, I am just getting lost in the process.
Nitty-gritty.
Or if I tell my accounts manager that send me all the checks that you prepare for my signature,
correct,
then I will spend 1 hour a day just signing checks.
Right.
Right. I don't need to do that. I have to
correct,
trust something. I have to trust a process. I have to trust an audit. Whatever it is, I have to do that so that I am kept free.
Correct.
For taking really consequential decisions which impact my company, its earnings, its future, and its progress.
Right.
I think the same principle applies to foundries in every aspect of its working. And I am now talking about sand. So it also applies to the person who's handling the sand.
Correct.
Right. If I was running a foundry and my foundry manager would come and tell me, sir, we added 2 kilos of this, or we did this, or we did that, I would listen to him with due respect, but at some point I would wonder that whether I have got the proper processes in place.
Right. So I have something very important to add on the part that you mentioned about the sand. So you said that it's not the foundrymen's fault because they've never had access to this technology where they could test sand on real world conditions.
Yeah.
Right. But things are changing today.
Yes.
Now it may take some time to catch up.
Yeah.
Like as you mentioned, maybe 3, 5 years, 10 years, we don't know.
Yes.
So understanding this, if we have a good foundry manager today and they are maybe in their 30s, 40s, 45, 50 maybe, right? They're not from the earlier generation where you never had access to these technologies, but at least now they have some testing equipment.
Yeah.
Right? How can they leverage their testing equipment best with the current access to technology that they have? How should they be testing today? What is, in your opinion, what's the best way to test?
Yeah. So as I told you, the development of real world condition testing technologies has still not percolated down to the industry as a whole.
Right.
So I think we are still where we were 50 years ago.
Okay. It's that bad.
It's that bad, yeah.
Right.
Use the word for a better phrase, it's that bad. It's bad because, as I told you, now there is an imbalance between what you are designing for and what you are actually getting. So you're designing for a sand system based on sanitized laboratory conditions, and you are getting performance based on real world conditions in the sand mold, which is highly dense, much denser than what you were used to before, which is highly intricate because patterns are becoming more intricate. The integrity of the mold has becoming more demanding. So your disadvantage between what you have and what you are designing for, the arbitrage gap has increased rather than decreased.
Okay.
Even if you had all the sophisticated equipment we are talking about, and you still do not understand why bentonite performs the way it does, or what should be the test that should be conducted on the bentonite in order to understand its balance and performance in a sand system, you have still not touched the surface of control. As I said, once again, we have testing processes which are age old. We have parameter checkings which are age old. So I have actually tried my level best to see that I keep on talking about the technology of the usage of my materials. I delivered my first, I actually delivered a presentation on the role of carbonaceous additives, a paper which is referred to even today in 2008 in Chennai, and it is there on the net.
Right.
And then I subsequently delivered another paper on the same subject, but with enhanced information, is the role of carbonaceous additives and the role of total carbon in the sand system.
Right.
Many of those ideas that I propounded are followed by even my competitors today, right? It doesn't bother me because that's a part of growing up and maturing in the industry. Sometimes the ideas you say is followed by others to your disadvantage, maybe in commercial terms. But commerce is not what motivates me today. It does motivate me when I'm sitting on the chair of MPM's chairmanship.
Correct.
But since I fashion myself more as a technologist, I feel it is my duty to inform the reality of the process in stark contrast to what is happening today, and actually tell them that what is it that we should be looking at. Sometimes you don't even have the ability to buy all those machines to be put into your laboratory because of the cost of using those machines to understand the crucial performing properties of, let's say, even coal. We test coal, for example, for LOI and volatile matter. But how many people understand that there is a mid-level of volatile organic compounds? How does that impact the evolution of gases in the mold? How many people understand the difference between black coal, brown coal, lignite? There are so many types of coal. Hard coal, soft coal. I mean, Foundrymen would say it's not my job to understand that. I look at the constituents of coal, that is the ash, moisture, VM and LOI. That's good enough for me. Really? Yes. Fundamentally, by a thumb rule, it is good enough. And you are not expected to know more.
Correct.
But maybe a little bit of more insight into understanding why clay swells the way it does. Why is hot sand considered to be detrimental to the development of clay? What is deeper in understanding the loss of clay during the casting process, whether you are losing 80% of it or you're losing 60% of it, or whether you're losing 35% of it? At what level does the dehydroxylation temperature reach? That is when your clay becomes totally ineffective, and when you do TGA tests on it, for example. I have a TGA machine in my laboratory which costs about 35 lakhs rupees, for example. I can't expect a foundry to invest in that. But as a supplier, I try to give information on that wherever the foundry needs it or tries to appreciate it.
Correct.
I won't do it just out of default conditions.
Right.
You know, so I will draw a stark contrast even to what used to happen when I started my career and what happens today. When I started my career, grand old men of the foundries, I mean, I am testament to their thinking, progressive thinking, I would say. They would say, Deepak, I've got a problem, I've got blowholes in my system. Come and help me solve it. It was an order and also a collaboration. Right? Young man then, you know, so people like, you know, I won't take names, but I have deepest respect and admiration for them, and I had the good fortune of knowing many of them. They would just say that by exception, is that a coincidence that 10 people in 10 different foundries would adopt the same approach with me individually? I've got a problem of this type, can you help me solve it?
Correct.
Today, we are told as suppliers, now I'm wearing the hat as a chairman of this company, these are the specifications that I want. You deliver as per these specifications and at this price. So now you tell me that if you are going to look at any aspect of the foundry industry in this manner, what is the role of the supplier to you? He is no longer a supplier, he is a complier of your requirements.
with the variables that you have specified.
Yeah. This is where I am trying to highlight that the intricacies of the product that you supply should be known, and that I should know how to apply that into your system so that I can deliver a system to you, a solution to you.
Correct.
So we need to nurture the aspect of collaboration beyond commercial terms, beyond commercial requirements. It's about what the additive performs in the system to give you lower rejections. For example,
Correct.
if you are able to control rejections by 1% and a 75 lakh rupees is probably not what you are buying the value of that of my material to that level.
Correct.
So if you look at the macro of the entire functioning, you can be much more efficient, and that is what Sandman is all about. We become agnostic to man, material, and machines. I don't care whose material you are using.
Correct.
I don't care which machine it is being applied to, and I don't care who's applying it, as long as you are following it as per the process that you need to apply it. Like you're using your iPhone, you have to use it in the way it is supposed to be used, right? You try to fool around with it, it's going to hang.
Correct.
Right?
Doing what is not meant to be done with it.
Yeah. Right. You have to follow even a process even when you are using a phone.
Correct.
Yeah. Don't click on dangerous links.
Correct.
For example.
Correct.
So the same thing applies to the systems that we are working in, we are performing in. We have to change the mindset that we stop micromanaging, that we stop heavy lifting, we let technology do that job. And why did high pressure lines come in, by the way? Because the customers started demanding high integrity molds, highly precise molds, and highly consistent molds, so that you could make highly consistent castings, which was not possible on a jolt squeeze line or an ARPA line.
Right.
That was the transition of the industry from jolt squeeze lines to high pressure, high density molding lines.
Correct.
Right? The same thing applies to the subject that I am talking to you about. Why should sand remain grey? There is a scientific ability to control sand. Sandman is that.
What you've done with Sandman also, to add to your point, you've taken, it's a culmination of all your many years of learnings of, being a consultant, being a flying doctor, solving Foundries problems, taking all that knowledge, which is not wasted, and putting it into one software, which basically is like, your message to the world. I think that is essentially what you've done with Sandman.
Absolutely. You have articulated it very, very succinctly. And I would also give credit to my customers, because I say that Sandman is a co-creation. I have faced heavy demands and heavy flack from the users, all in good faith, by the way, who said, I want this also, Deepak, can you do this also? Or this is not up to it, let's try to see whether we can incorporate another angle to this. And we did that, and the software is therefore actually the knowledge bank of my logic, but co-created with the demands and the logic of the ecosystem that I apply this software in.
Right.
There's all these companies. So there is no individual claim to fame, except the fact that yes, it is a pioneering effort.
Right.
That is something that did not exist. It is a 0 to 1 pioneering effort, as people say now, that you start from 0 and you have gone to 1. That is the crucial thing that I lay claim to. I think that we are on the forefront of technology transformation in the industry, but not to sound that that I am doing it only to sell my product, but it is basically to give a concept of the effort that is going in taking away the daily, repetitive, and inefficient methodologies of doing any process.
Correct.
And letting artificial intelligence, which is the buzzword of today's world, to give you that output.
Right.
Leaving you free to focus on designing the entire process. Design is much superior to
managing.
Right.
So I think what people mainly want to know is, this is a revolutionary product. how did you go about formulating the idea for it? How did you bring it into crystallized form, into actually being on your computer as a a software? What is that process like? When did it first start? How did you go about it, and how long did it actually take?
Yeah, so that's a interesting question that goes deep into my history. I don't know whether I should answer that. So any relevance to your so very frankly, I won't go into the actual bingo moment of my getting into. So I was always scared of software. I would run away from any letter S.
Okay.
Because I never thought myself capable of developing any software. But it so happened that I was doing a case study on analytics where I don't remember the exact thing, but it was a case study about two young guys trying to impress one of these big two, I think whether it was Steve Jobs or whether it was Bill Gates, I'm not clear, on a certain process where they had to showcase their analytics and they were not ready for that meeting. So how they did that analytics loop in a very small designed ambience and showed him the power of their software that they were developing on an analytical basis for a specific problem. I don't remember exactly because it's been almost 10 years that and it was a bingo moment for me. And I went to people whom I respect and I said, I need to get into this. How do I do that? They said, I won't say that. That's a secret that I have.
Right.
So, long and short of it, I found the right people who would code it for me. I was never aspiring to be the coder. And the global patent that I have is on the concept. You cannot patent an algorithm, but you can patent a concept and an algorithm which is connected to a machine. So this Sandman doesn't operate by itself just out of the cloud. It is a cloud software, but it needs machines to deliver the results, right? The computer is a machine. Sometimes it interfaces with the HMI or the SCADA of the systems and then delivers the result. So without a connection, it is of no value. The algorithm is of no value.
Correct.
Right. So that's how I developed it. It was done in 2011, 2012. Took me 3 or 4 years to develop the prototype and took me another 2-3 years to bring it to maturity, proof of concept.
Okay.
By the way, one of our customers is the first and the only foundry of its type in the world where there is no human interface between the prescription of our recipe of each batch of sand that is prepared to the dosing of the additives with an eye on the rejections. It is completely software driven. No foundryman will ever allow you to touch the dosing of the additives. But it is being done by them for the last 2 years and they have record lower levels of rejections.
Okay, it means your software automatically not only makes the calculation but also carries them out.
Yeah, it makes the calculations, it gives a recipe that for the next batch you add A, B, C, D in the following quantities and it predicts what will be the properties of sand once you do that.
Okay.
Even before you have tested it, right? And that is with an eye ultimately on the rejections, right? That's a very complex phenomena. So I think it is to the credit of Munjal Kiryu that they tested our software, they used it and they developed enough confidence to say we will go 100% with software driven approach.
Try best at least, summarize Sandman in one line for me or maybe a couple of lines. Like at its core, what does it do for a foundry?
So the tagline is it converts sand from art to analytics.
Right.
So it's a 3-word answer. But a complete answer is that it helps the foundry or it enables the optimization of the green sand preparation process to be able to deliver cutting edge process control of the sand loop, the sand system, not just the green sand, to be able to deliver very good casting outcomes achieved by optimizing not only the balance of the sand, but also the consumption of the additives that go into the sand. Almost every foundry in the world either overdoses or underdoses the sand system.
Right.
Foundrymen don't have data support. So what happens if you don't know what the return sand active clay level is, how do you know how much to make up in order to achieve 8.5? You don't know whether the return sand is at 7.2, 7.5, 7.8 because of the core sand dilutions. These are all technical aspects. So what the Foundryman does in order to achieve his target of 8.5, he over edges the bentonite. So what happens is that he might achieve 8.5, 8.7, sometimes 8.8, depends. Now what does that do? In foundry technology, and I have delivered papers on this, lesser is better. The lesser you add, the better your sand system behaves. The more flowable it is. The less of contamination that you have to treat additives as a contaminant, not as an additive.
Okay, that's very powerful.
It's a perspective.
Right.
Right. So it's also there in my book, by the way.
Right.
The analogy is that if you and I go to a doctor, say we have got fever, he will prescribe paracetamol. Crocin, Dolo 650. You know,
Correct.
the famous Dolo's COVID.
Correct.
Now why? Because Dolo is available in a strength of 650.
Correct.
But you might need 350, I might need 550.
Correct.
But we have no option but to take 650.
Because it's standard.
It's standard. So we are being either overdosed or underdosed. I might need an 850 with my BMI.
Correct.
Now imagine a situation where the doctor had control on the tablet and he has a tablet 3D printing machine with him.
Correct.
And the API, the drug formulation, right? Now he would say, okay, Jan, you've come here, you've got fever, I'm going to give you, you don't need to buy a 10 tablet strip. You need only 5 tablets, take it twice a day for 2.5 days, and you need 321 grams of paracetamol.
Correct.
By calculation, and he prints out 321 and gives you 5 tablets. What an ideal situation would that be?
Correct. Not only is it better for the consumer,
yeah,
it also saves resources.
Resources and unnecessary dosing of a human body.
Bringing down cost.
Yeah.
I think at that same talk that you gave, you also compared the doctor with, dosage as per BMIs, different BMIs.
That's what I'm saying.
Right?
BMI.
So, correct.
I'm heavy, I might need 750. You might need
right.
only 550 or 450, depends.
Correct.
So, and this kind of treatment, by the way, is prevalent in high critical disease like cancer.
Right.
Where chemo is dosed by need. You never overdose a chemotherapy because you might kill the patient. So, I tell foundries, that if you want to understand the real value of prescriptions or advice in foundries, so if you come to me and just say that I want to have a solution, and you come to me without data, you're like going to a MBBS doctor in an OPD clinic and he'll say, please take a paracetamol and go home. Then you go back to him after 2 days, my fever is not coming down, I'm feeling worse than before. Then he'll say, go and get some blood tests done. What is he doing? He's collecting data.
Correct.
And then he will treat you by data.
Right.
And then he will tell you, take this antibiotic for 5 days also. Because now he knows what to treat.
Right.
But if you don't give him data, he doesn't know what to treat. He's just treating you by clinical examination.
Correct.
Right? Which may not be 100% accurate.
Or could also be guesswork.
Yeah.
Which could be fatal.
It is actually most of the time
right.
experiential understanding. Blood tests give you data-based insights.
Right. I think that brings us onto our next point. You said a major USP of you creating Sandman was that we have an aging foundry population.
Yeah.
Right. And experience is something that is mainly driving foundries today.
Yes.
But that cannot be, extended and cannot be forever.
It cannot be, and also understanding that there are 2 aspects of this, and it's very rightly said, and you picked up that point from my presentations very well. It's a very crucial point, and this is starkly understood in the States where I go, because there is an aging senior management population there. They understand that because there also foundries are 100 years old.
Right.
Unlike in India, there are very few foundries that are 100 years old. Over there are many foundry groups, etc., which are 100 years, 75 years, 125 years. Now they have got people just don't leave and go. They normally stick to the job. They have high value.
Correct.
This used to be there in Indian foundries also, until say about 20 years ago.
Correct.
Now there is a constant churn of people because of more opportunities, more different kinds of experiences.
It's also the culture today.
The culture also,
right.
maybe I would say, okay, fine, culture, or maybe they want different experiences.
Right.
The fact remains that there is a churn. How do you handle a 20-year experienced guy leaving your foundry tomorrow, even with a 60-day notice? Is he going to transfer 20 years experience in 60 days? That too in the absence of annotations. Yeah, 20 years to transfer in 60 days, very difficult to do that.
Right.
Especially when the guy who's expected to transfer doesn't have an annotation or a notation system where he can actually transfer everything, and he should be inclined to do that also.
Yeah.
Many people don't transfer experience, let me tell you.
That's the main one.
Yeah, it's an uncomfortable fact, but it is a fact.
Right.
You got to love the guy whom you're transferring to in order to transfer your experience to him.
You also have to be really loyal to the company, and in which case you wouldn't be leaving in some cases.
Not necessarily. There are times when you have to retire, when you...
Right.
I wouldn't go into the personal aspect, but yes, you have to really love the guy or really be interested. And as you said, to even love your company or feel that sense of responsibility to transfer it. But it's also physically not possible.
Correct.
So Sandman, for example, has a module which is an annotation-based module. So we annotate the experience of the foundry on a daily basis. On every single aspect, we encourage them to put an annotation. That we will transfer to artificial, and where you ask the software, when did I have blowholes more than 5% and what did I do to resolve them? I'll give you an answer. That's going into the future. But today it will at least give you clear marks on run charts and line charts and everything, process control charts. What were the times you had blowholes and what was the after and before effect of certain changes that you made in the system.
Correct.
This is of crucial importance where you institutionalize experience rather than rely on personal experience. You know, whether it's you or me or anybody,
correct.
I think that is necessary as we go forward.
It's a very big USP.
Yeah.
So I think I want to talk about, probably give us some good case studies where you've gone and implemented Sandman, right? And you could see a very good change. Like maybe if you have numbers, metrics, or maybe whatever change that you could observe where there was a proper implementation and what exactly it can do for foundries who actually take it seriously.
So there are many instances, but things which I will tell you which stand out in a complete stark contrast to, I mean, in stark, what do you say, effect. I remember we had a case when we were implementing, Sandman was being implemented and they were having scab defects. And we were sitting across, all of us across the table, and Sandman predicted that you need to control the pH value of the sand. pH was being tested, but everybody across the table said, I mean, Mr. Chowdhary, I mean, are you serious? We just test pH because we test it. I mean, I never imagined that pH has any relationship with scab.
Okay.
I said, but sir, this is a highly sensitive algorithm. It is showing it as the most influencing factor for scab.
Correct.
Why not give it a shot? So how do we do it? So then we go into domain. So either you add a little more soda ash to the system, right? Or you analyze what is acidic, like, you know, more coarse sand going into the system, whatever it is, and try to increase the pH value to 9, which they did. The scab disappeared within 2 days.
Amazing.
Amazing. These are the kind of vignettes or insights, or like, take for example, something which surprised us also, we have a variable compactability control algorithm, which is one of its, only of its kind in the world again. We have a patent on that. Now, compactability is controlled by the ambient, by the actual temperatures and humidity of the sand, and by many other factors, which people don't know and they don't understand. And they think, you know, most foundries, you will be surprised, the compactability control is a straight line. I call that a dead man's line. It's only a dead man who has no heartbeat.
Correct.
There has to be a heartbeat in the system. If somebody gives me a straight line, I'll say you're doing something wrong or you're fudging the system.
Correct.
Right. So we we implemented variable compactability control, and the foundry, I think, I won't name the foundry, in one foundry, and we found that blowholes reduced by over 72, 50 or 72% just by tweaking the compactability by 0.5. And can you imagine that foundries do not even touch compactability for a week at a stretch? You've got 45 now, and let's say it rains, and your compactability is not going to be the same on the mold. So your performance will also not be the same. You need to embrace technology, not leverage technology. Technology is available for leveraging. What is missing is your embrace of technology. So what I say is embrace technology. Technology doesn't happen because it's available. A lot of technology is available. And everyone can wax eloquent that my technology is the best. Are you ready to understand and embrace technology? This is the question that every foundryman should ask himself or herself.
Correct.
What really amazes me, and I think that if I was to talk to foundries on a very personal level, how many foundries have an artificial intelligence driven organization meeting at least once a month in their foundries?
As to the use cases that could be,
or just to understand what is this, and not the buzzwords,
Right.
Most of the time when we talk about artificial intelligence on foundry platforms and this thing, that's not really true artificial intelligence only when you mimic the human intelligence. Like for example, our sand mix algorithm, where we give a recipe of the sand before it is mixed. Now that is based on all the data that we have, we make a prediction of the recipe, right? That is not available on a normal basis. That is, prescription is artificial intelligence. Prediction is not artificial intelligence. Machine learning is towards artificial, is virtual artificial, but not true artificial intelligence. So that's why I said that the ability to articulate your needs and the way forward, clearly define it, is what is going to take us to the next level.
So given this, now obviously there's a cost factor attached, right? Who do you think is an ideal foundry ready to adopt Sandman today? Given the cost factor aside, they also need to have the infrastructure, the testing platform, the amount of production. So who would you say is an ideal foundry right now? How would you categorize, and maybe what persona am I looking at?
What if I told you that every foundry is a candidate for Sandman?
Okay.
And I will give you the reason why I say this.
Right.
I will give you a story. There is a story of an American sailor, Lieutenant Maury, in the 1800s, I think 1800, mid 1800s, right? Young man. He was deployed on a battleship and he was returning home after a particular assignment. Most unfortunately, his carriage, they had horse-driven carriages, overturned, resulting in the loss of both his legs.
Okay.
26, 28-year-old
right.
Soldier, Now, the Navy offered him a job in a room, bare room with one table and chair. To his destiny, I would say, not his luck, but his destiny, that room contained the logs of all the captains of all the American ships which were sailing around the world. This gentleman, what he did, he started reading the logs. And every captain has to record for the day the route, the tide, the wind, the current, the temperature, and everything of his surroundings where the ship is sailing before going to sleep. It is mandatory. And that log is kept under lock and key, by the way. Okay. Because in the event of a catastrophe, accident, or investigation, that is relied on as testimony.
Correct.
Now, he was credited for developing the world's first wind and current chart. Because he started sending those charts to 1,000 captains of American ships sailing all around the world. And he cut short the sailing time by analytics, mathematical analytics, from San Francisco, from New York to San Francisco from 180 days to 90 days. Now, if that company has to move forward, not for Sandman, but within its own ambience, because 1% rejection control is 1% increased competitiveness against your competitors.
Right.
More money in your bank. And the most important thing about rejections, Ian, is not about the money or the loss. If you reduce rejections, you are perceived as a more reliable foundry with your customers.
Correct.
No customer likes a foundry which is doing a lot of rejections.
Correct. In fact, I think we should go into unseen waste, which you were telling us a little bit about.
I have this very famous quotation of a very famous gentleman. Engineers have heard about him, but I don't know how many foundrymen have heard about him. Shingo, the production manager of Toyota. His statement resonates with me very powerfully. The most dangerous type of waste is that which we do not recognize. Feel the power of that sentence. That means you are seeing that waste, but you are not recognizing that as a waste. And I'll give you a classic example. In foundries, I would say bad batches is a classic example of this waste, or unpoured molds even. Why? Because you make 1,000 molds and you don't pour 50. The mold has been made, the cost has been incurred.
Correct.
But you did not pour because there was something wrong with the mold.
Correct.
So you wasted that.
Right.
The mold costs money to make. Not to mention the amount of castings that were not poured, and therefore the efficiencies that you lost.
Right.
The operational efficiency of the machine.
Correct.
Now that is a waste which is right in front of you. You are recording that waste. I didn't pour 50 molds. But you are not recognizing it.
And the impact that it has on your profit.
Yeah.
Right.
Or a batch of sand which goes bad because the compactability was not achieved. It sends it back into the system. I've heard many foundrymen tell me, oh no, but we didn't waste anything. That has gone back into the system. The additives have gone. But can you track the additive?
Correct.
Do you know when it is coming back from the return sand hopper for the next mix? Are you going to reduce the bentonite because you know that that has come back? No way.
Correct.
And I'm using this very specifically. No way. You know what's happening. So what has happened? You've lost it. Recognize that.
At least then you can improve from there.
That is when you start improving. The moment you start saying, yes, I know that this has happened. Let's try to figure out a way how not to let it happen.
Correct.
That's my approach.
That's great. And lastly, I want to talk about today sand is considered a resource. Right?
Yeah.
We hear about the recent mines closing in the south. So how do you think foundries could approach conservation of sand? Is this a threat that you feel that is coming up in the near future, or maybe in the next 10, 15 years? And what is your take on the subject? I just want to hear your perspective.
So that's a great question. Number one, all the additives that go into sand are natural resources. Bentonite, coal,
correct,
sand, and water. It's a coincidence, but it is a fact. All four are natural resources.
Right.
And all four go into what we call finally toxic sand. Sand disposal is known as toxic. Right?
Correct.
Now, by overdosing and underdosing prevention, by this algorithm which prevents over and underdosing,
right,
sand mix algorithm, we have proven case studies that we are able to conserve between 10 to 15% of additive consumption on all four counts in the first year of operation.
Okay.
So if a bentonite is being purchased at 2,000 or 5,000 tons a year, which is not a big deal for a big foundry, and you say 15%, you're saving close to 500 to 750 tons of bentonite. And
per foundry.
Per foundry.
Right.
So if foundrymen want to talk about conserving sand and the cost of procurement of sand, before they talk to their suppliers to reduce that cost, they should first try to reduce the consumption of their costly additives. I tell that to whoever cares to listen, and I am sometimes brutally frank about this.
Right.
Because when you look at it as a cost, you are looking at it with a positive lever trying to squeeze the cost.
Correct.
But when you look at it as a waste, which can be prevented, you are automatically conserving the cost.
Right. It's just a framework.
It's a framework. That's what I said. The articulation of the problem leads to a great solution.
Amazing. I definitely learned a lot. Thank you so much.
I was happy because you have been a patient listener.
Yeah.
Which everyone is not.
In fact, I've been always coming up with a rebuttal to whatever you said earlier. And this, I think, one of the few podcasts where I've not had to look at the script. I think I just glanced down a couple of times just to make sure we are on track. And everything flowed really well. We finally reached the end. And I'd like to ask you, is there anything that you think we missed out that you would like to add?
Oh, no. I think I'm also very happy that you have started this initiative of podcasts, which I think will bring great value, because you will be talking to many people like me, smarter than me, more experienced than me also, and some people who would like to be at that level. And from each podcast, I expect people to learn from the experiences of others. I don't need to add much. I only need to reiterate that every single book that you read, every single hearing that you have, from whomsoever it may be, brings a lesson in realization of what could be improved in our lives, in our professional lives, in our personal lives, and in the way we look at things.
Correct.
And if I was to say that an essence of my discussion here, it's not about my product or my journey, etc. But if I was to distill the experience, again, let's say in a single line or statement, is always about articulating the problem, defining the parameters in which you want to operate and want to see, to enable you to arrive at the right answer and the right solution. A wrong articulation will get you wrong results. A considered articulation will always get you good results. You have to have a problem statement in order to have an answer to that problem. So what I'm essentially trying to say, that if the problem is not defined or articulated accurately, you are still a little further away from your
answer
solution.
Correct.
And my life journey, and as I go along, I'm realizing more and more that the real advancement is not about technology, because that is going to advance whether you and I are around here or not.
Correct.
There are people who are going to keep on touching the frontiers of technology and beyond.
Correct.
What is important is finally is how do we embrace the fact that technology is evolving and that we need to evolve along with it, and that we need to get on board with it, and where we don't understand it, we have to try to understand it by not just thinking, oh, how do I understand data analytics? That is not embracing technology. How do I need to first articulate my problem statement and then bring the power of modern analytics, etc., to solve it? The problem is the first point of action.
Correct.
Everything else follows.
And also recognizing that there's a problem.
Yes, without that there is no articulation.
Right, because I think we also spoke a little bit about how ignorance can come into play and affect your judgment as to, oh, there's no problem right now.
Yeah.
So maybe the solution will not be as clear.
Yes. What would you like not to see when you arrive in your foundry in the morning?
Yeah, as you asked me, my rejections are only X, Y, Z.
Yeah, when people use the word only 5%, I mean, that really sends a question mark. Question.
Right. That's great. Yeah. So I think before closing, you have some CSR activities that are going on. I just like you to highlight.
Oh yeah, that's a wonderful point. So very relevant, in one of the executive education courses that I did, the professor of that university said that you have done probably 600 case studies here with us, and if there is one thing that I would like you to take away is that please go and join a non-profit organization.
Okay.
do good beyond your business. I have always felt that I have a unique ability to understand some aspects and problems of the foundry industry. So I have always wanted to start an academy to educate the next generation of foundrymen, right from the student level to whichever level that they are today, if they are interested in learning. And as a consequence of that, we have started the MPM Academy, MPM Foundry Academy, am I correct? The concept was my concept, but it has been driven by my group managing director, Mr. Ashok Vishwakarma. We have actually formulated several modules which are active and are available to those who are interested to onboard it. And we have a great talent pool in MPM, very senior foundrymen who have years and years of technical experience, right? And all that is going into this software delivery of education. So that is my level at which I am, that's my dream or my ambition. And I believe that will be a great help for practical solutions for aspiring foundrymen as well as people who are in the foundry industry who want solutions to everyday problems. So those who are already then, they should have an aspiration to learn more.
Right.
And those who are at the younger level, they should have an aspiration to also learn more. It's all a question about learning and recognizing that you don't know everything.
Correct.
And there is always a better way of doing something.
Correct.
Right. We may not be the best, but we will certainly deliver on a corporate responsibility basis whatever we know.
Correct.
So that the skill set of the succeeding generations at least continues to develop and that we have a role to play in it.
Right.
We will always look at it with pride. And not only will we develop that generation, I think somewhere along that line, people will remember the good that we have done.
Right.
Right. So that is what we are doing.
Yeah. So thank you for listening. Thank you, Mr. Chowdhary, for your time.
Thank you, Ian.
Right, and for sharing your experience. And
it's been a pleasure.
You can where can we find your book?
On Amazon.
On Amazon, yeah. So we'll put the link probably below, and you guys can check it out.
Yeah.
That's good. Thank you so much for listening, guys. And yeah, thank you.
Thank you, everybody.